Welcome back. So we have a problem to solve. Integral of 1 over hyperbolic sine of z with respect to z evaluated along a circle or in a circle whose radius is 4 units. So the first thing we do here is to identify the f of z and then find the poles of f of z. So solution here, f of z is given by 1 over hyperbolic sine of z. So this is the same as saying 1 over sine of iz, because hyperbolic sine of z is the same as sine of iz. So next, we find the poles. By solving hyperbolic sine of z, which is the same as sine of iz, is equals to 0. Now, the values of z, which will give us sine of iz to be 0, are n pi I, where n is an integer. So with these values, out of this, false, only z equals to 0, z equals to negative pi I, and z equals to pi I lies inside the circle. So the circle is specified to have a radius of 4 units inside the circle. Please note that pi is roughly 3.142. So when you draw a circle, the specified circle is having a radius of 4. So this is 4, this minus 4, this minus 4i at this point here, and this other one is 4i. So this is the real axis, this is the imaginary axis. So here we have 2i, then minus 2i, say 2, and then 2, and then it's negative 2. And you see our z values of the poles are n pi I, where n is 0, plus or minus 1, plus or minus 2, plus or minus 3, etc. So 0 is within this circle. And then plus or minus so it's like we have 0, plus or minus pi I, plus or minus 2 pi I, plus or minus 3 pi I, etc. These are the poles. But then pi is 3.14. So 3.14 times 1. So 3.14 will be roughly somewhere here. Negative and then the positive. But then when you put twice times 3.14, you get 6.28 plus other decimals. So that will be outside the circle. So these are the only, this point, and this point are the only point that lies within circle radius 4 units. So now let's calculate the residues at each of these poles within the circle C. Now, the function f of z 1 over hyperbolic sine of z is of the form phi of z over psi of z. So where our phi of z is 1 and the denominator is the hyperbolic sine of z. Now, since f at n pi is non-zero and this one at n pi is 0, then to calculate residue at pi I, z equals to pi I, we use the formula phi prime at pi I, phi at pi I over the derivative of the denominator at that point. This we saw in the introductory parts. So the phi of pi I remains to be 1. Derivative, so we just write d dz of hyperbolic sine of z evaluated at z equals to pi I. So that will be 1 over derivative of hyperbolic sine is hyperbolic cosine. You apply this one at z equals to pi I. This 1 over hyperbolic cosine of pi I. And when you work out, this one is the same as saying 1 over cos of pi I. Cos of pi I is the same as cos of I pi I, which is the same as 1 over I times I is -1, so cos of negative pi. So this will give me -1. And then residue at z equals to minus I pi will be pi at minus pi I over the derivative of the hyperbolic sine of z at z equals to minus pi I, which will give 1 over hyperbolic cosine of minus pi I, which is the same as 1 over cosine I times minus pi I. So that's the same as just cosine of pi. Cosine of pi, which is the same as -1. So cos of pi then cosine of. So those are the values we get. Then residue at z equals to 0 will be the value of the numerator at 0 over d dz of hyperbolic sine of z at z equals to 0, which will be phi at 0 over cosine, hyperbolic cosine at 0. And this will give us the numerator at 0 is 1. This is the same as hyperbolic cosine of 0 is 1. So this gives us 1. So by Cauchy's residue theorem, the integral along C, 1 over hyperbolic sine of z dz will be given by 2 pi I times residue of the function at 0 plus residue of the function at pi I plus residue of the function at minus pi I. From our calculation, will be 2 pi I. Residue at 0 is 1. Residue at this is negative 1. Residue at this one is negative 1. So which will give us minus 2 pi I, because this 1 and 1 cancels out. And so this is the value of the given integral. Thank you.